Hi, this is Martin Mayer from Foundry and welcome to today's Workflow Wednesday session. Recently I was faced with a question from our customer how we can create radial gradients inside of Nuke to add distortion and shockwaves to their footage. So today I would like to share with you a few ideas how this can be accomplished. All of them vary in terms of complexity and performance. So let's have a look at the way this can be done. Before we dive into it, let's have a look at the way this is actually accomplished at the end when you're actually distorting the pixels by your distortion map. So here I'm creating a distortion map, then this is being fed to a node that will actually move and warp the pixels, and here we have the final result. This can be accomplished in Nuke by using two nodes. It's either the STMap or the iDistort node. I prefer to use the STMap. We have also a GPU accelerated STMap node that comes with Kara in Nuke 12. So now let's build the gradients. The first approach that I would like to show is the most labor intensive, I guess the most manual, but for quick setups it's quite valid. So first I start with the ramp, then for this I just created a ramp that goes from 0 to 1 or 0 to the full resolution of the screen, and then you can easily adjust the way this spreads. Then I'm tiling it or flipping it, mirroring it by tiling it. The reason why I'm doing it this way is that then I have only one point to control the whole width of the gradient on both sides. I'm tiling it a few more times to get a few stripes, and then this allows me to just flip it or move it around. And then at the end I'm using spherical transform that is doing most of the work, and I'm essentially converting the lat long to angular map 360. So when I look at it this way, I'll get a nice radial gradient in there. If you need to use this then or animate this, it's easy as adding a transform at the end, and it will result in a nice radial gradient animation. The obvious problem with this is that you're limited by the scale, and eventually you'll run out of the iterations on the gradient in there, so your shockwave is limited in terms of time. To allow our gradient to run forever, we need to create a gradient that can loop, and for that we can use the expression node to create something like that. So let's go ahead and create one, and I'll just connect it to the input and let's have a look. So if I type in, let's say, y into my red channel, you'll see that now I have values that are decreasing from the full resolution of the frame all the way down to 0 if you watch the red channel here. To get the undulating effect, where we have a gradient going up and down, we can use the sine function, and that will return the sine of our y value. So let's implement this. Let's go ahead to Nuke, and I will add sine and then brackets to close our y into those brackets. And you'll see I'll get very rapidly changing gradient. To decrease the frequency of our gradient, we need to divide the y value by something more useful, let's say 50. And now the intensity decreased, or the frequency decreased. We have a problem though. If you watch the red channel, again here, we are going from +1 all the way down to -1. And I would like to keep this between 0 and 1, this gradient. To fix this, let's do a little bit of basic arithmetics to offset the numbers. So I'll add +1 to this. That will get me to values from 0 to 2, as you can see, 2, almost 2, and then 0 here. And then what I'll do, I'll just close this all to brackets and then divide it by 2 or multiply it by 0.5. And that will get me between values that are 1 and 0 right down here. Good, so we fixed this. Now we need to make the gradient move. And the easy way to do this is to add a channel that will be animated and will be added or subtracted from our y value. So to do that, I'll just go ahead and enable my edit mode, drag a floating point slider that will create a user tab for me. I can click this edit circle and let's call it face. And let's give it a label as well. Good. So with our channel created, now we can add it to our expression. Let's just go back here and let's say face. And then let's subtract it. So it will jump a little, but now we have a control over the movement of our gradient. So I'm going to go ahead and add a few keyframes. So let's set a keyframe here maybe, and towards the end, let's set it to maybe 3. And then let's see what we are getting here. Perfect. So from here, we have two options. We can either use the spherical transform as previously, which will give us a gradient that will be moving and growing forever. So it's much more suitable for any distortion effects like a shockwave, for example. Or alternatively, you can use the polar distort gizmo from Wikipedia that will allow you to calculate the polar distortion much faster. The expression approach can be extended much further, where we combine all these tools into one. In this case, I'm using the sinus curve that is generated based on the hypotenuse instead of on the y-axis. And that will allow me to combine and calculate radial gradients directly inside of one tool. So I have the same level of control. The face is behaving as previously. And also I have control over the size. And most importantly, I have a center that I can calculate the whole expression from. Great, so now that we have our gradient ready, we can use it in our ST map. For that, let's prepare a simple UV map. So in another expression node, I will divide the x coordinate by the width. That will give me a gradient that is going from 0 to 1, or normalized gradient that is going from 0 to 1 across the width. And I will do the same for the height. So y coordinate divided by height will give me another gradient that will create a UV map. We can then use our radial gradient and merge it with the screen. This little setup will give us a control in the ST map over the strength of the deformation. To connect it all, let's create an ST map node. And I will connect my footage into the source. And into the ST map input, I will connect my gradient. So now when I look at it, nothing will happen because we need to define the channels that will move the pixels around. For that, I will use RGB because my merge or screen operation here creates RGB channels. From here, I can control the strength by dialing in how much of the gradient is merging with the UV map. I can add various noises and develop the effect even further. Thank you for watching. I hope you found this useful. If you're looking for more information, you can find it on our website under the expression section. Alternatively, you can go to Wikipedia and there is a Expression Node 101 article that covers a lot of aspects that might be useful in your daily work. Happy comping!